Hi to everyone, myself Prabhu. Today we are going to discuss about fuel cell. Fuel cell is an electrochemical device which generates DC electricity based on the electrochemical reaction. Here the electrochemical reaction is basically oxidation and reduction. The fuel cell, where we are going to see about the synapses, what is meant by fuel cell, and then fuel cell components, and then applications. Before that, we are going to basically see about the fuel cell. Fuel cell is a device that converts the chemical energy into electrical energy, and the byproducts are water and then electricity. Okay, fuel cell is the proton exchange membrane fuel cell. This is one of the type. Here the protons and then electrons will be exchanged in order to generate electricity. Fuel and air react when they come into contact with the porous membrane. This is the porous membrane, which is electrolyte. Okay, this electrolyte, fuel and the air which come into contact. Here the H plus ions and the O2 minus ions combine. Here the H plus ions in the anode side, reduction takes place. In the cathode side, oxidation takes place. Addition of oxygen is called oxidation, and then removal of oxygen is called reduction. Here in other terms, loss of electrons is called oxidation and gain of electrons is called reduction. In the anode side, the fuel H2 is the hydrogen fuel, which is in H2, the anode side, the hydrogen will be flowing through the anode side, and the cathode side, oxygen will be flowing through the cathode side. Here the gas diffusion layer, GDL layer, will be segregating the gas, and then electrolyte will be acting as a catalyst. Here the anode, from the anode side, the H plus ions, 2H plus H2 plus ions will be break into 2H plus ions and electrons. These electrons will be conducted through an electrode, which is connected to a load. This reaction results in a transfer of electrons and ions across the electrolytes. The electrons will be transferred through this load, and then ions will be transferred through this electrolyte membrane. So this is why it is called as proton exchange membrane. If an external load is attached to this arrangement, a complete circuit is formed. In order to get the voltage, we are connecting the cells fuel stacks by series. In order to get the current, we are going to combine the fuel cells in a parallel manner. Okay. This voltage generated by a single fuel cell will be rather than in terms of millivolt, less than 1 volt. Okay, so many cells are connected in series to get the higher voltage. Okay, this is the basic history. Fuel cell, which was developed by William Brook in 1839. Okay, these are the groove cells in which the oxygen and then hydrogen will be formed into 4 groups. Okay. Grooves which is used for large cells which containing hydrogen and oxygen in order to produce electrical power, which was used to split the water. Here the byproduct is already told that the water is the byproduct. The first fuel cell is demonstrated by NASA in 1960s. This is the first fuel cell which is developed. Okay. The fuel cell research, and after that the fuel cell research has been actively taking place since 1970s, which is resulting in order to overcome the conventional source, the fuel cells are replaced by the non-conventional source. This is the overall reaction terminology which is used in the fuel cell. First one is electrochemical reaction. The reaction involves the transfer of electrons. Okay, and then electrode. Electrode is a terminal that conducts electric current to the fuel cell, and also to the load, and then anode and then cathode. Electrode where oxidation takes place. This is electrons are released, and then cathode, electrode where the reduction takes place. Electrons are acquired. In a fuel cell, the hydrogen is oxidized at the anode, and then oxygen reduction occurs at the cathode. Electrolyte is a chemical compound that conducts ion from the electrolyte to the ion. Next one, the atom that carries a positive charge. Okay, the 2 H plus ions is the positive ion, and O2 minus is the negative ion. Okay, here is a positive or negative charge due to loss and gain of electrons. Okay, anion is a negative ion and cation is a positive ion. And then catalyst. A catalyst is a substance that participation in the reactants in order to increase its rates and not in terms of not consumed in the reaction. Okay, polymer. The next one is a synthetic compound are made up of giant molecules which are composed of small molecules, simple molecules, that is called monomers. Next one is the inverter. Okay, we are deriving only the DC current. In order to acquire AC current, we have to invert. That is the device which is used to invert the DC current to AC current, alternating current. A device used to convert DC direct current electricity produced by a fuel cell to alternating current. Then the reformer, the device that extracts pure hydrogen from hydrocarbons. Here we are using only the pure hydrogen, because if that any composition means the fuel cell will not be efficient. If there is addition of the other gases like nitrogen, it will affect the efficiency. Then stand is the group of fuel cells that individual cells are connected in series with a generating assembly. Okay, these are the applications of the fuel cell which is used in the stationary systems. This is the passive proton exchange membrane fuel cell which is used to generate about the most powerful electricity, which is about 250 kilowatt. Okay. The next one, this is the stationary system which is used in submarine. These are the 80 kilowatt power plant which is used by the German submarine. And then for transportation systems, vehicles like four-wheelers, that is bus. This is the first bus which is it is developed by Exelis. This is the prototype developed by the Exelis. This is the phase 1 and phase 2. These 4 phases will increase the efficiency of the fuel cell. Buses are most commercially advanced applications for fuel cell till date. These are currently used by American and European countries. Okay, this is the example of a fuel cell car. Honda, which is developed the fuel cell car by using the hydrogen as a fuel. Okay, the main advantage of fuel cell is that the hydrogen, which is combined with the oxygen, which produces the byproduct as a water. It is not polluted, but rather than non-conventional sources, conventional sources, the solar, like thermal, hydro, it produces the pollution. Okay, next, this is the main cause. The coal is the major source for thermal power plant. It produces the main disadvantage is the pollution. Okay, this is pollution free. So we are moving to this conventional type of resource, non-conventional type of resources. Many of the major car companies are developing for the future generation in order to use the hydrogen as a fuel in order to overcome the petrol, crude oil. Okay, and then this is the type of a fuel cell which is used by a car. Okay, this is the fuel tank, hydrogen tank. It is normally the fuel filled by the hydrogen in order to activate the not to generate the electricity. This hydrogen is supplied to the fuel, normal fuel. Okay, hydrogen is supplied to the fuel cell, and this from this where the oxygen from the air is combined with the hydrogen in order to generate the electricity which is stored in the battery in order to use for the applications in the car. Okay. The chemical energy, here there is no generation of electricity. One form of energy which is converted to another form of energy. Here the chemical energy which is transformed to electrical energy, and then electrical energy is transformed to mechanical energy. This is the law of conservation of energy says. There is no creation of energy. We are segregating the chemical one form of energy to another form. This is the fuel cells used in space systems. It is a 12 kV space shuttle fuel cell which is weighing about 120 kg. And then this is 1.5 kilowatt Apollo fuel cell. These are used in the space stations. And then fuel cells in use in portable systems. Nowadays, this type of cells are replaced by lithium ion, and then which is used in computers, laptops. A laptop using a fuel cell which can operate up to 20 hours. This is the 100 watt fuel cell stacks. These stack cells are formed in a group. In order to achieve the voltage, we have to connect the cells in a series manner. In order to get the current, these are connected in the parallel manner. Okay, most of all, this is the hydrogen is really the hydrogen is explosive. No, but the hydrogen in a safe manner, in a controlled manner, is not explosive. Okay, that's all. Thank you for listening. Have a nice day.